Let us consider an example. So this is a water level control system. So we have the input flow here, which will be controlled by control valve, and we have the level measurement here to measure the height or the level of the tank, and we have the output of the tank, which is not regulated at all. So meaning that the output of the tank, the flow rate, will depend on the height. If the height or the level is high, the output flow rate will also increase. But if the level is low, the output flow rate will also drop because it is based on the gravity of the liquid. Okay, so now to control the water level to maintain at one level, we will include a controller here where the controller will have level set point. Let's say this is the set point, and the controller will use the level measurement to observe the process variable. So based on this observation from the sensor, the controller will determine what is the controller output, whether the opening of the control valve is sufficient to maintain the level, or the controller need to change the opening, whether to increase or to decrease the opening of the valve. Let us give one scenario. Let us assume the water level drop. Once the water level drop, the controller can detect that the level is dropping, and therefore the controller will send control signal to open the control valve. So the control valve will be open and more flow rate will flow into the tank, which will cause the tank level to increase. Once the level has been increased to a set value, the controller will send signal to the control valve to reduce the opening to make sure that the water level maintain at the set value. So this loop will be repeated over time. However, this is by assumption. This control is fine by the assumption if the flow rate from the input, flow rate to the input is well regulated and stable. So the problem will be significant, or the performance of the controller will drop if the input flow rate is not regulated or is not stable. Sometimes the flow rate is high, sometimes the flow rate is low. So the controller cannot control quite well to maintain the water level due to unregulated pressure or the flow rate from the source. So this will become a problem to the controller to meet the performance requirement. Therefore, in this situation, we need to do some modification or improvement to the existing controller. To solve the problem, we introduce a secondary loop here, where we can see a secondary loop will have it feedback, it measurement and controller. So the secondary controller will measure the unstable or the unregulated flow rate by using a flow meter, DP cell flow meter. So this DP cell will send the flow rate information to the flow controller, and this flow controller will regulate the valve opening based on the set value. So if the set value is high, then the control loop will make sure the flow rate is also high. If the set value is low, the controller will make sure the flow rate is low, regardless the flow rate from the input. So the outcome of this control loop is the flow rate is well regulated as required by the set value. So the source of this set value is the primary loop controller. So coming back to the original problem, the controller will send the controller output, which will become a set value to the secondary loop, and the controller will only monitor the level. If the level drop, the controller will send the flow rate signal. So in this case, without cascade controller, the controller will send signal of valve opening. But here, in this case, the controller will send the set value in terms of the flow rate instead of the valve opening. So all the problem due to the unregulated flow rate is now handled by the secondary control loop. So the performance of the controller, which is the water level, will be much more better as compared to the controller without cascade.